Welcome to the debate. If a tree falls in an empty forest with no one around, does it make a sound? I mean, most of us hear that question and immediately think, well, of course it does. It just feels like basic common sense, right?
Yeah, it really does. But that simple riddle actually completely split the world of philosophy hundreds of years ago. And surprisingly, it continues to challenge our understanding of modern physics today.
Exactly. And the reason we are exploring this topic is because we recently came across a really compelling conceptual framework. It maps this old philosophical riddle directly onto modern quantum mechanics.
Right. The designed by Hut.
Yes, exactly. It is an intricate model, specifically designed by Hut, that basically forces us to reconsider the most basic rules of our daily lives. It asks one core question. Does the physical universe actually exist when we are not looking at it? Right, and today I will be arguing that things only exist when they are actively observed or perceived. So I am defending the view of the 18th century philosopher George Berkeley and also the perspective of modern quantum physics. Basically, without an observer, reality is just, well, a blur of possibilities.
And I am taking the opposing side. I will be defending the view put forward by the 17th century philosopher John Locke. I will argue that physical matter, the solid stuff that makes up the universe, exists completely independently of us. The forest, the trees, the earth, they are all there regardless of whether human eyes are looking at them.
Okay, well, let's start with Locke's perspective, since it basically represents how most people navigate their daily lives. How exactly does his view handle that falling tree?
Right. So Locke argued for a concept known as materialism. This is just the idea that the universe is made of actual physical material. Rocks, water, wood, stars, they're all solid objects with physical properties like weight and size. According to Locke, this physical matter exists out there in the dark entirely on its own.
Okay.
So, when the tree falls in the empty forest, it crashes into the dirt. That crash creates intense physical vibrations in the surrounding air. Those vibrations push the air molecules outward in a wave.
But a wave of air isn't a sound. I mean, it's just moving air.
Well, it is the physical mechanism that creates sound. The air molecules ripple outward, and if a human ear happens to be nearby, those moving air molecules physically crash into the eardrum.
Right.
They vibrate the tiny bones in the ear, sending an electrical signal to the brain, which we then experience as a sound. But here is the crucial part. Even if no human is there to catch the wave, the air is still vibrating. The physical event still happened. Reality is stable. Because without this baseline common sense rule, we would basically have to assume the universe stops working the second we turn our backs.
Yeah, but you say the air is still vibrating, but you are assuming the air exists when you aren't feeling it. And this is exactly where George Berkeley introduced a really radical alternative.
Which is?
Berkeley argued that there is no underlying physical matter at all. None. He claimed that the only things that truly exist are our sensory experiences, what we see, what we hear, what we touch. His famous rule was, to be is to be perceived.
Wait, really? So he believed that physical objects are just an illusion?
He believed that we have zero evidence for physical objects outside of our own minds. Let's look closely at your falling tree. You described a physical chain reaction, right? Ending with the brain experiencing sound.
Right, exactly.
Berkeley points out that the sound is entirely an experience happening inside a conscious mind. Take away the mind and there is no sound. But Berkeley goes even further. He applies this to the tree itself.
How so?
The tree is just a collection of sensory experiences. It is the color brown, the rough feeling of the bark, the smell of pine. Take away the eyes, the hands, and the nose, and, well, what is actually left? You assume there is invisible matter holding the tree together, but you can only ever interact with your own senses.
Okay, I have to jump in here because I completely reject the idea that matter vanishes when we stop sensing it. It clashes with everything we observe about the universe.
How?
Let's use a massive, undeniable example. Think about the moon. When I stand outside at night and look up, I see the moon.
It is bright, it is huge, and it is made of billions of tons of rock. If I squeeze my eyes shut, I am no longer perceiving the moon.
Right.
According to Berkeley's strict rule, if it is not being perceived, it ceases to exist. Does the massive, rocky moon just pop out of existence the moment I blink? And when I open my eyes, does the universe instantly rebuild the entire moon in a fraction of a second? I mean, that sounds totally absurd.
Well, you think it sounds ridiculous because you are still imagining the moon floating out in space as a solid rock. But how do you actually know the moon is there?
I know it is there because of gravity. The moon has massive physical weight. That weight pulls on the Earth. It creates the tides in our oceans.
Okay.
The ocean does not have eyes. The ocean does not have a mind. It cannot perceive the moon. Yet the physical gravity of the moon pulls millions of gallons of water toward it every single day. This physical interaction happens whether human beings are standing on the beach watching it or not. The physical laws of the universe operate entirely on their own.
But how do you know the tides happen?
What do you mean? Because we measure them, we see the water rise.
Exactly. You measure them, you see the water rise. Every single piece of proof you have about the moon or gravity or the tides is just another sensory experience happening inside your own brain.
But
Let me just finish this thought. Berkeley was pointing out a structural trap here. We cannot separate reality from our perception of reality. You cannot prove the moon exerts gravity when no one is looking, because the only way to prove gravity exists is to look at its effects. We are entirely trapped inside our sensory bubble.
But you are ignoring the consistency of the physical world. If the moon only existed in my mind, then my reality would be entirely subjective. But it isn't. You and I can stand next to each other and point to the exact same crater on the moon.
Right, we can.
We share the exact same physical reality. The most logical, common-sense explanation for that shared experience is that a giant, independent rock is hovering above both of us, reflecting real photons of light into both of our eyes.
Okay, so you mentioned photons of light, which actually takes us directly to the strongest scientific support for Berkeley's philosophy, physics.
Physics?
Yes. When we look at how the universe actually operates at the most fundamental level, we don't find solid rocks. We find quantum mechanics. And the rules of quantum mechanics sound exactly like George Berkeley.
okay, so you are talking about the behavior of microscopic particles like electrons or single photons of light.
Right. When scientists study the tiny building blocks of the universe, they discover that these particles do not act like solid pieces of matter. Before a scientist looks at a quantum particle, that particle does not have a specific solid location. It does not sit in one place like a tiny rock. Instead, it exists as a wave of probabilities. It is everywhere and nowhere at the same time.
Right. This is a state called superposition. The particle is basically existing in a blurry mix of multiple possible states.
Yes, it is a mathematical blur. But here is the critical, proven scientific fact. The exact moment a scientist measures that particle, the exact moment they observe it, the blur instantly collapses.
Okay.
The act of measurement forces the particle to choose a single definite location. The observer is literally required to make the reality solid. If no one is observing, the universe remains a blurry wave of possibilities. The moment someone looks, the universe becomes solid matter. Berkeley said, "To be is to be perceived." Quantum physics says, a particle only becomes solid matter when it is measured.
I mean, I understand why the observer effect seems to support this idea, but we really need to look closer at what measurement actually means in physics.
How do you mean?
It is not about human consciousness or perception. It is about physical interaction. Think about how we actually observe an electron in a laboratory. We cannot just look at it with our bare eyes. Electrons are far too small.
Sure.
To see an electron, a scientist has to shoot a photon of light at it. The photon bounces off the electron and hits a detector. That is how we measure where the electron is.
I agree. That is how the measurement happens.
But that is exactly why the electron state changes. We literally hit it with another particle. The act of measurement is a physical collision. It is not our mind or our perception that forces the electron to become solid. It is the physical machinery we use to look at it. The physical world is just interacting with itself.
Well, that is a common defense,
but modern physics experiments have actually ruled that out.
Really?
Yes, scientists have designed deeply complex experiments, like the delayed choice quantum eraser, where the measurement happens without physically disturbing the particle in that way. And the result is exactly the same.
Interesting.
Even when we don't physically bump into the particle, simply having the information about its path causes it to act like solid matter instead of a blurry wave. It really is the information, the knowledge, the observation that changes reality.
Okay, but even if we accept that information changes the state of a single isolated microscopic particle, it simply does not scale up to our daily lives. I mean, a falling tree is not a single electron. A tree is made of trillions and trillions of particles. Once you put that many particles together, they're constantly interacting with each other.
But every single one of those trillions of atoms is fundamentally a wave of probability. If the building blocks aren't solid until observed, why would the building be solid?
Because of a concept in physics called decoherence. It explains exactly why the macro world, the large world we live in, stays solid.
Okay, explain that for me.
When an electron is totally isolated in a cold laboratory vacuum, sure, it can act like a blurry wave. But a tree in a forest is not isolated. The atoms in the tree are vibrating with heat. They are bumping into air molecules. They are absorbing sunlight. Every time an atom in the tree bumps into an air molecule, they exchange information. They measure each other.
Oh, so the tree is observing itself?
Exactly. The environment is constantly measuring itself through physical interactions. The trillions of tiny collisions lock the tree into a solid, definite state. This happens continuously, endlessly, regardless of whether a human is walking through the forest. Decoherence proves that large objects do not need a conscious human mind to stay real. Physics forces them to stay real.
Well, that assumes the physical universe is the base layer of reality. But the conceptual framework we are exploring today, that designed by Hut, it actually connects Berkeley and the observer effect to something even more fundamental.
Which is?
Information theory. Specifically, the idea of simulation theory.
Simulation theory suggests that our entire universe might be a highly advanced computer simulation.
Right. Think about how modern video games are designed. In the early days, a computer would try to calculate and draw the entire game world all at once. Every tree, every mountain, every cloud.
Sure, yeah.
But that used far too much computing power. It was incredibly inefficient. So modern programmers use a technique called dynamic rendering.
Which basically means the computer only creates what the player is actively looking at.
Precisely. If your character is inside a small room, the game's computer only draws that specific room. The massive forest outside the window is left completely blank. It exists only as unrendered code in the computer's memory. It saves processing power. The graphics only load or render when your character walks outside and looks at the forest. The trees literally only exist when the player observes them.
And you are applying this video game logic to the physical universe.
I am applying it directly to quantum mechanics. Why would the universe keep unobserved particles in a blurry wave of probabilities? Because it saves processing power. Calculating the exact position of every single particle in the entire universe at all times would require an infinite amount of energy, so the universe just doesn't do it.
It leaves the forest blank.
Exactly. It leaves the unobserved forest as a blurry wave. The moment you walk into the forest and look, the universe instantly renders the solid particles into existence. Berkeley wasn't just describing philosophy, he was describing the processing tricks of a simulated reality hundreds of years before computers even existed.
I mean, the video game analogy is structurally clever, I'll give you that. But it completely falls apart when you look at the historical timeline of the Earth. A video game only renders the present moment. But our physical universe has a deep physical history that existed long before any human eyes were here to observe it.
What kind of history?
Think about dinosaur fossils. The dinosaurs lived, hunted, and died roughly 65 million years ago. There were no human beings to perceive them. There were no conscious observers measuring their actions. Yet they left physical bones buried deep in the rock. We dig them up today. If the universe only renders reality when we look at it, how do you explain a 65-million-year-old fossil? Did the simulations suddenly render millions of years of fake history into the dirt just because a paleontologist picked up a shovel?
Actually, yes. In a simulated environment, a computer can procedurally generate backstory the exact moment it is needed. When you open a book in a video game, the text inside generates at that moment. The computer creates the fossils to ensure the rules of the simulation remain consistent when you look for them.
But do you see how incredibly complicated that explanation becomes? We have a principle in logic called Occam's razor. It basically states that the simplest explanation is usually the correct one.
Okay.
What is the simpler explanation here? Option A, the entire universe is an impossibly complex computer that randomly generates fake dinosaur bones and fakes the laws of gravity just to trick human eyes whenever we happen to look. Or option B, the Earth is a giant physical rock. Dinosaurs were physical animals that died and left physical bones. The universe exists independently of us, and we are just small creatures walking around inside it.
While simple does not always mean correct. The history of science is full of simple ideas that were wrong. It was simpler to believe the sun revolved around the Earth because that is what our eyes told us. But the truth was far stranger. The deeper we look into quantum mechanics, the more we realize that objective physical matter might be the illusion and information might be the base layer of reality.
I still maintain that we have to rely on objective facts, not just subjective observation. Physical matter has real consequences. If a bridge has a structural crack in its steel, that crack is a physical reality. It is dangerous.
Right.
It does not matter if no human being has looked at the crack yet. The bridge will still collapse under the weight of a truck. The physical laws of tension, gravity, and mass will break the bridge entirely without an observer. We have to respect physical reality because it acts upon us whether we believe in it or not.
Look, nobody is arguing that you shouldn't respect the rules of the environment. If you are in a simulation, the rules of the simulation still apply to you. A cracked bridge will still cause you to fall. The profound shift here is not about ignoring physics. It is about our place within it.
What do you mean by our place?
We walk around believing we are just passive witnesses to the universe. We think reality is a stage that was already built before we got here. But when you combine Berkeley's philosophy with the quantum observer effect, you get a much more empowering view. We are not just tourists. Our observation is required. Reality is a deeply interactive process, and by observing it, we are actively participating in bringing the universe into focus.
Wow, okay. This is a tremendous amount of complex material for anyone to process. To make sure we leave everyone with a firm grasp of these two opposing viewpoints, let's summarize where we both stand on the falling tree, especially for our younger listeners or anyone new to this.
Yeah, I think a really clear summary is essential, especially when we are talking about unrendering the universe.
Let's do it. So, I will recap the materialist side. My position, which is grounded in John Locke's philosophy and the regular physics of our daily world, is that the universe is solid, objective, and real. Matter exists completely independently of our minds. When a tree falls in an empty forest, it absolutely makes a physical sound wave. Trillions of interacting atoms constantly bump into each other, and this locks reality into place without us needing to be there. Things like gravity, dinosaur fossils, and a cracked bridge prove that the physical universe has its own rules and its own history. Basically, we discover reality. We do not create it.
And my position, which is based on George Berkeley's ideas and modern quantum mechanics, suggests that reality is a team effort between the universe and the observer.
Right.
The universe at its base layer is not made of solid rocks. It is made of probability and information. Without an observer, a falling tree is just an undefined wave of possibilities. The act of looking or measuring is required to collapse that wave into a definite physical reality. Just like a computer saving memory by only drawing what a video game player looks at, the universe relies on our observation to become real.
Exploring these ideas really shows how a single ancient question can evolve over time, connecting 18th century thoughts on perception to 21st century simulation theory through that design by framework has been a really remarkable exercise in logic.
It really has. It is a great reminder that science and philosophy are constantly talking to each other. The rigid laws of physics keep our daily lives predictable, but the quantum mysteries remind us how little we actually know about what is happening behind the curtain.
Exactly. And we will leave it to the listeners to decide which side they find more convincing. Tonight, try a simple experiment. Step outside and look up at the massive, bright moon. Feel its presence. Think about the gravity pulling on the oceans.
Yeah.
Then, simply close your eyes. Stand there in the dark and ask yourself, did the moon just dissolve into a blurry wave of probability? And are your eyes the only thing bringing it back into existence?
It definitely changes how you experience the night sky.
It really does. Thank you for joining us for this intellectual journey. We will catch you next time.